Today I want to share with you a project I'm working on to create a modified controller for the Vectrex. And controller that seems to work the best and that you see plans for on the internet a lot is the Sega Genesis controller. And people like to use this one because it has the requisite number of buttons that you need for a Vectrex, and the plug on the end is almost identical to the Vectrex plug, so you don't have to do a lot of modifying there. Just a little background, this is the original Vectrex controller, and while it's pretty good, it doesn't really fit in your hand that well, and it has an analog joystick, which is it makes some games a little challenging to work on. Whereas the Sega Genesis controller had the benefit of a few more years of development, 16-bit game system, and so it's a lot more comfortable to fit in your hand, and it works better for arcade-style games. So I've made these in the past, and I've done it using a hand-wired technique where it looks something like this, where I pull the board out of the controller, and I cut a bunch of the traces on it, and I solder wires right to the board, and I add a little bit of a few resistors into the circuit, and then I take all of this mess here and I jam it back into the controller shell, which looks like this. The tricky part with this design is that some of these boards that are inside the Genesis controllers, and I have a whole slew of them here, they're all a little different. Some of the boards, like this one for instance, the traces are nice and thick, really easy to cut them and to solder to them. This, on the other hand, is one with really tiny traces on it and all surface mount chips. It's a lot harder to hack. What I did here is this is one of my boards that I've actually gone ahead and soldered leads onto, and you can see how tiny all the traces are there that I've had to solder onto, and then there's a big blob of hot glue right here that holds the wire in place so it doesn't tear loose. But you can see where I've even had to drill holes in the board to feed wire through from the back so that it would all fit. And you know, this works fine, and I've actually sold a bunch of controllers that I've made this way, but it's really time consuming. There's a lot of things that can go wrong. There's a lot of trial and error and testing along the system. What I'd like to do is design a whole new board to replace this one entirely. So the idea would be I could disassemble the controller, take the old board out, throw it away, take my new board that I create with all the parts on it already, stick it in there, solder the connector wire right to the pads on the board, put it back together, and I'm good to go. What I'm going to do is walk you through a little bit how the Vectrex controller works and why we're able to convert a Sega Genesis controller for the Vectrex. And I'm also I'm going to explore some other controllers. Like here's a Super Nintendo controller. And I can actually modify this also for the Vectrex because it has 4 buttons and a D-pad. And in fact, it's got 6, but we just need 4. And frankly, I like this controller better, aesthetically speaking, than the Sega Genesis. I've done the Genesis so far because it's a bigger controller and there's more room inside for me to hand wire the board. But if I'm going to make my own boards, then maybe this controller comes back into reality for the Vectrex. So let's go take a look at how this works, and we'll go from there. The joystick or the D-pad on the Sega controller is digital, which means that each direction, left, right, up, down, is either on or off. It's either a 1 or a 0. This controller, on the other hand, is analog, which means it's a variable. Up and down, left and right. And I made a diagram over here to kind of explain how that works. So you can see here that at the rest position in the middle, the joystick is outputting 0 volts, both on the x-axis and the y-axis. So the joystick actually has 2 variable resistors inside, one for x and one for y. And both positive 5 volts and negative 5 volts are feeding into the controller. And it outputs based on where you move the joystick. So it's outputting 0 on both axes in the middle, if I was to move the joystick over to the right, then I'm outputting 3 volts here, still outputting 0 volts on the y-axis. If I wanted to plot a point, say right here, I would have to move the joystick until I was positive 3 volts, so 1, 2, 3 volts on the x-axis, and positive 2 volts on the y-axis. So how does that work now if we're going to use a digital controller? Well, the important thing to understand about the Vectrex is that most of the games, even though the joystick controller is analog, most of the games on it were programmed for a digital output, which means they basically just faked it. They took this controller and they decided that they were going to just pick up a point on this graph and say that the 0 became a 1. So when the joystick's at rest in the center, that would be a digital 0. As soon as it exceeded a certain voltage in any direction, let's say 3 volts, then it would consider that to be a 1 and it would move the character or whatever in that direction. By putting some resistors in the circuit, you can actually just press the button and feed it the amount of voltage it's expecting to see to generate a 1 instead of a 0. Alright, so I took my circuit boards and I threw them on a flatbed scanner and I scanned them into the computer. So here they are on the screen. And what I discovered is that depending on the type of board, of which last time I did a batch of these controllers, I found 7 different styles of boards. So over the years, Sega used at least 7 different manufacturers or designs, and this is just in the large style controller. Now the smaller style controller that came with the Genesis 2s and 3s has a whole different circuit board in it. But anyways, they're almost the same. They're all wired the same, but what I have to watch out for is where the mounting holes are, because they're slightly skewed in some of the designs. So what I wanted to do is come up with a design that would be more or less universal. So I would just mark all the drill hole spots and drill it in such a way that I could drop the circuit board into any style of the Sega Genesis controller casing and it would fit in there. So let me show you how I went about this. Let me turn on. So I took one of my circuit boards and I put it in the background, and I'm using a program right now called Freehand, which is, it's like Illustrator, and I use Freehand only because I own it and I've used it for years and years, so I know how it works, and I just haven't taken the time to get into Illustrator. But here is the scan. So what I was going to do is trace my circuit board outline and my traces right onto this photo, and that way I can get the board exactly the size I need it and lay my traces down and put the switches exactly where they need to be. So let me turn on the foreground and you'll see that there is my first crack at the circuit design. And if I turn the background off, you can kind of see it. So you'll notice, first of all, one thing I learned from the Vectrex Light Pen project is that on that project I just had traces and everything else was just, the copper was removed. So you start out with a copper clad board, right, and then you put your design on it with the toner transfer, and then it eats away all the copper that's not covered with toner. Well, what happens is if you have a lot of copper to remove, then your etchant wears out very quickly, and it takes a lot longer to etch the board if there's a lot more copper on it. So what I did is I filled any empty space I could with black so that the copper would not be removed in those places. And frankly, it doesn't matter if there's copper there or not. So I went ahead and just filled it in, and just, you got to make sure in your design that you're not shorting anything out by doing it that way. But you'll see that I added my logo and some text there that says Vectrex controller board, and this is inverted, so the text is backwards so that when it's transferred it'll be forwards. You can see in the corner here where my drill holes are actually, there's 2 sets of drill holes here, and that's for the different variations on the controller type. So my next step now, I've gone over this circuit a couple of times. I'm not using a circuit design program which would tell me if there were any opens or shorts. I'm just kind of going old school here. And I've looked the circuit over 2 or 3 times. In fact, I've done so many of these controllers that I know the circuit by heart. So I'm 99% sure this is right. And I'll just do one as a test and then wire it up, and we'll see if it works. Alright, I know I got a little long-winded there, but I just wanted to share with you my thought process going into this project. And I'm about to go ahead and get started with the first prototype board. So I'm going to head down to Fry's and get some parts. I'll talk to you later.